In that last section, I was discussing how it's only the outer subatomic particles, the electrons, that are involved in chemical bonding or chemical bond formation. So in chemical reactions, atoms transfer or share electrons. In the example we see here, an atom of sodium loses an electron, transferring it to the chlorine atom here. Okay? So that's one way that a chemical bond can form. What happens when an electron is lost by one atom and picked up by another, so it's lost and then it's gained, what occurs is that the atoms then become charged, ions. And the reason that happens is the electron, if you remember, has a negative charge associated with it. So when the sodium atom, all by itself, it's chemically neutral, has no charge, but when it loses an electron, that electron takes a negative charge with it, and it adds it to chlorine. And what happens to chlorine? It becomes a negatively charged ion. An ion is a charged atom. So, again, the sodium loses a negative electron. Because of that, it becomes positively charged. And the chlorine picks up a negatively charged ion, so it becomes negatively charged. This can only happen if these two atoms are close to each other. So now you have two ions that have opposite charges because there's been an electron transfer. Electron's been lost and gained. So now these two things with opposite charges are next to each other, close to each other. They will link together to form a chemical bond. Kind of like on the opposite north and south ends of magnets. You hold two magnets together, clink, to form a bond. This is called an ionic bond because it's a bond between ions. The ions are formed because of the transfer of electrons. Okay? So that's one kind of chemical bond. So the interactions between atoms, and it's going to be involving the electron specifically, forming a bond, is called a chemical bond. So ionic bonds is the first type of bond we considered here. An atom will lose an electron or so, and then that means the other atom has to pick it up. The transfer of electrons generates ions, which are charged atoms. And because of that, the ions will be oppositely charged. They'll form a chemical bond, and that's called an ionic bond, okay, between oppositely charged ions. But what generates the ions is the movement, transfer, loss, and gaining of electrons. It's the electrons that are involved in the chemical bond formation. Okay? So, for example, plain old sodium chloride, table salt, is formed by ionic bonds between sodium and chlorine. So a little video on ionic bond formation. Hopefully this will play for us. I'll crank up the volume and listen along.
Sometimes atoms complete their outer shells by stealing or giving away electrons. This happens between sodium and chlorine atoms. An electron moves from the sodium atom to the chlorine atom. The outer shells of both atoms are now complete, containing 8 electrons. The chlorine atom now has 18 electrons but only 17 protons. Because an electron has a negative charge, the chlorine atom now has a net negative charge. Such a charged atom or molecule is called an ion, in this case a negative ion. The sodium atom has lost an electron, leaving it with an extra proton, which has a positive charge. The sodium atom has become a positive ion. Ions with opposite charges are attracted to each other, forming an ionic bond. These ions combine to form a compound with new properties. In this case, sodium chloride, ordinary table salt, is formed.
Okay. So next are covalent bonds. Another type of chemical bond. With covalent bonds, this occurs when atoms share one or more pairs of electrons. Again, it's the electrons that are involved. So covalent bonds are the strongest type of bonds that are holding atoms together in molecules. And again, we can say compounds. We can use these terms interchangeably. Technically, a molecule is a substance combining similar elements, like the same elements. Like oxygen is two oxygens linked together, meaning oxygen gas. And a compound is different elements like, say, water, two hydrogens and one oxygen. But we can get away with using these terms interchangeably, molecules and compounds. Okay? So covalent bonds are the strongest bonds in molecules, and it's because at least one pair of electrons are shared between the atoms. So a little video on covalent bonding.
A covalent bond is the sharing of a pair of outer shell electrons by two atoms. For example, each of these hydrogen atoms has one electron in its outer shell, but needs two electrons to complete its outer shell. If the two hydrogen atoms share electrons, they can both complete their outer shell. The shared pair of electrons constitutes a covalent bond, shown in shorthand as a line. The covalently bonded hydrogen atoms form a molecule of hydrogen gas. A molecule is defined as two or more atoms held together by covalent bonds. An oxygen atom needs two electrons to complete its outer shell. Two oxygen atoms can share two pairs of electrons. A molecule of oxygen gas is held together by a double covalent bond, two shared pairs of electrons. A carbon atom needs four electrons to complete its outer shell. It can share electrons with four hydrogen atoms, forming a methane molecule containing four single covalent bonds. Methane is a compound, a substance formed by the combination of two or more elements. We call methane natural gas. It is the fuel burned in gas stoves and furnaces. An oxygen atom needs two additional electrons to fill its outer shell. Thus it can form two single covalent bonds. An oxygen atom can share electrons with two hydrogen atoms, forming a molecule of water containing two single covalent bonds.
So it's getting a little complicated there in a way, but the main thing is that, let's see if I can take this back a little bit.
Bonds.
Yes.
Methane is a compound.
So here's methane, something called CH4. Well, the chemical formula is CH4, meaning one carbon and four hydrogens, and it's called, the substance is called methane, a natural gas. But notice what's happening. Here's a carbon, and the very center is going to be the nucleus with protons and neutrons surrounding it, and the electron cloud or the electron shells are its electrons.
Forming a methane.
And the blanks here, the open circles, indicates additional electrons that carbon can pick up. All right, so carbon, it forms stable compounds or molecules if all of these missing electrons are filled, and it can do that by combining with up to four different things in the sense of four hydrogens.
The molecule containing four single covalent bonds.
Whoop. Sorry, what happened there? Ah, that's what happened there.
It can share electrons with four hydrogen atoms, forming a methane molecule containing four single covalent bonds.
So here are four hydrogens coming in proximity. So the hydrogens, that's the smallest element, only have one electron. And by combining with carbon, the hydrogen can share its single electron with carbon, and carbon can share one electron with hydrogen. So these two electrons, the blue spheres, meaning an electron, the open spot sphere means there's no electron there, but carbon wants to pick up an extra electron. So again, it's just the combination, the interaction of electrons. It's one pair here to form a covalent bond here. Here's a second covalent bond being formed, hydrogen and carbon. Here's a third one, and here's a fourth one. The circles represent what are called electron shells. Hydrogen is the smallest element. It only has the innermost, smallest electron shell. It can occupy 2 electrons. Hydrogen is like all lonely by itself. It wants to pick up a second electron. It can do that by sharing an electron from carbon and filling its electron shell with 2 electrons. Carbon, it's a bigger substance, a bigger element. It has 2 electrons in its innermost electron shell. Its outermost electron shell only had 4 when carbon's all by itself. It can hold up to 8. Carbon can fill its outermost electron shell by making 4 chemical bonds in this case. Here we go, the chemical bonds are formed. The number of electrons is the same, except now they're being shared. The straight lines indicate chemical bond, straight line between hydrogen and carbon, and the straight line indicates 1 pair of electrons. So this is just a shorthand way of writing this thing that actually shows the electrons and the electron shells. So these are covalent bonds. They're stronger than ionic bonds, and covalent bonds are formed by sharing electrons between different elements. Okay? So let's look at water next. We'll look at water next.
A substance formed by the combination of 2 atoms. An atom needs 2 additional.
So here's oxygen. Like carbon, it has 2 electrons in its innermost shell, but in its outermost shell it only has 6. 1, 2, 3, 4, 5, 6. It needs 8 to fill its outermost shell. And these are a few details we won't get into that much, but it can pick up 2 more, and it will do so by
electrons to fill its outer shell.
Combining with 2 hydrogens. And again, hydrogen all by itself only has 1 electron in its outermost shell. It needs 2. It can pick up 1 by combining to form covalent bond with oxygen, and so can this one. And in doing so, boom, hydrogen now has 2 electrons in its outermost shell. This hydrogen does as well. And notice what's happened to oxygen. 1, 2, 3, 4, 5, 6, 7, 8. All the electron shells are filled because of the sharing of electrons. 2 electrons here between oxygen and hydrogen, indicated by the little single straight line. 1 covalent bond. The line indicates shorthand 2 electrons. 2 more electrons here between this hydrogen and the oxygen. There's the line indicating a chemical bond. All right? Okay. So, hydrogen bonding, or hydrogen bonds, is the third type of bond that we'll consider, and it's the weakest type of chemical bond. So, water is a good substance, molecule to investigate this hydrogen bond business. So water, H2O. And notice the shape of water. It's a bent molecule. The oxygen binds with hydrogens to form a bent molecule. It's not a straight line, a straight linear molecule. It has a bent molecule, which gives water a unique characteristic, chemical characteristic, that we'll talk about in a bit. So 2 hydrogens join with 1 atom by forming covalent bonds. This line, if you remember, indicates a chemical bond, interaction between 2 electrons. This is called a ball and stick figure, representation of substance, a molecule. This over here is the same thing, except it looks a little different. It's called the space-filled model. Oxygen, hydrogen, and hydrogen. This gives a more realistic shape interpretation of water. This is easier to interpret in terms of where the chemical bonds are, okay, and the shape or geometry of the molecule. Notice this is still kind of bent, or it is bent, okay? So there are covalent bonds, 1 chemical bond, 2 electrons interacting between oxygen and hydrogen there.